So hello again from my side. As Steve introduced me, I'm Matej. CREA is an 18 years old software development company. We've been focusing on development of software for enterprise-based customers like bank and insurance companies. But lately, we switched the gears and now we are in the Bitcoin. So what is Nakasendo? Nakasendo is software development kit for accelerating development of Bitcoin-based applications. It provides APIs on a different level of abstraction. So if you are an expert Bitcoin developer, you can take a low-level API where you can control every bit and pieces. On the other side, if you're a higher-level developer, if you want some business functions, you can take a higher-level API and you can execute higher-level functions. For example, just do a simple API calls to execute atomic swap on the BSC blockchain. So what differentiates Nakasendo SDK from other crypto libraries is that it implements some advanced techniques that were born by the Nakasendo, but by an N-chain research team. And you can use these techniques to implement some really interesting stuff. So, as Steve mentioned before, there has been some trolling around the Twitter and the internet, where is the Nakasendo, okay? So if those trolls would attend the geography classes, they would learn that Nakasendo is on the other side of the world. It's a train in Japan. But if they're asking about the SDK was released a little more than a year ago on a CoinGeek conference in Hong Kong. So the first version contained all the important stuff that is required by the crypto library, like it enables you to store secrets and metadata associated with it. It's fully implemented the private and public key cryptography that is used on the blockchain. And it implemented also two higher level techniques invented by N-chain. The first one being secure key splitting, that just enables you to take a private key, split it into different shares, and later combine it together. And the second one is related to common secret derivation, which is important if you have two parties communicating over the unsecured channel. The first version was written and implemented in C++, but was also exposed as Java. So quick question for this room. How many C++ developers are here? Oh, quite a lot, okay. But here we are today to talk about version 2, okay. Sorry to disappoint you. I won't be announcing any release dates of version 2. It's still being developed, but it's shaping out quite good. So today's presentation should give you a good idea of what to expect down the road. The upcoming version adds more low-level APIs. It implements big numbers library and elliptic curve arithmetic. It adds symmetric encryption and decryption, and also hashing functionality. More importantly, it also contains higher level functions. It contains the full implementation of SPV adapter, which enables you to publish transaction to the blockchain and to listen to the incoming transaction. It implements two flavors of the atomic swaps that you can perform on the blockchain. It contains support for Keypuzzles, and it enables you to do threshold signatures, which could prevent scenarios like Matej. So now another question for the audience. How many JavaScript developers are here? Okay, that's more, okay. After releasing the first version, N-chain listened to the community feedback and decided that we need to support new languages. So the upcoming Nakasendo will support JavaScript and Python in addition to the existing language. So, thanks. So the core of the Nakasendo is still implemented in C++, and this forms the base for a thin layer of language-specific adapters that takes the core functionality and exposes this functionality to target languages in a way which is most appropriate for this target language. As far as JavaScript is concerned, we take this C++ code and compile it to WebAssembly. WebAssembly is a binary instruction format intended to be executed on virtual machines that are stack-based. Actually, it is just a very efficient way to describe a computer program. It is designed to load fast, and it is designed to execute at speed that is comparable to native code. So without further ado, it's time for demo. What would be an equivalent of the Hello World demo for a crypto library? In cryptography, integers are used quite a lot. Not the small integers that we humans use, like I have one wife, 2 cats, 3 kids, and 2,000 friends on Facebook, but very large integers like with tens, hundreds, or even thousands of digits. And as I mentioned, Nakasendo supports big number arithmetic. Yes, it's true that the JavaScript is slowly getting support for this, and Python already includes the support for big numbers, but because the big numbers are building blocks of the API, it is essential that they are natively supported by the Nakasendo. So for the first demo, now you see my code. Okay, I'll do it's just a simple JavaScript calculator. Okay, so I have a web page that is running inside my browser, executing the C++ code that was cross-compiled to WebAssembly. So let's try something simple. So how many people are in this room? 12 rows. Oops. 12 rows by 12 seats. It seems the right number, okay? But good job, right? But it's a big number calculator, so let me try something bigger. I will say I will take a big number, 40 digits, and multiply it again with another big number. And we should get like 80 digits, yeah. That's a much bigger room. I think this is the number of atoms in a universe or something like this. And I can repeat this a lot of times. And you actually, digits are getting smaller because calculator is trying to fit it on the screen, but actual number is bigger. So I can easily go with thousands of numbers, okay? So this is simple demo of the Nakasendo big number library. So to check how it's implemented in the code, it's actually, we have a single class which represents a calculator with a single member which represents the current value, which is a Nakasendo big number. And then base of the entry entered on the keypad on the current operation, we just construct a new instance of a big number here and call appropriate operation on the on this Nakasendo big number. Okay, so quite simple. I know that this talk is titled Nakasendo library for JavaScript, but I couldn't resist, and I also included a Python demo. Okay, just to compare it with JavaScript. Can anybody tell me what this code is doing? Can anybody guess what it is doing? I'll scroll up a little bit, okay? We are on a Bitcoin conference, so we should be doing some elliptic curve. Yes, Python is great. Elliptic curves math, okay? We have a class that represents a point, and in constructor we just take a curve and x and y coordinates and check if the point is on the curve, because there is no point in having a point which is not on curve, okay? And then we have the operations on this point. Just a quick refresher how the points on elliptic curve works. You take 1 point, this is simplified geometry explanation, okay? You take one point, second point, draw a straight line through it, you will get the third point where the line intersects the curve, and you just flip it over, and that is the sum of 2 points. It's not so easy to guess the location of this point in relation to the first 2 points Actually, the security of the elliptic curves is based on the fact that it's quite hard to determine the position. So, and if you repeat this add operation many times, you can end up in a point which could be anywhere on the curve. And it's very hard to solve the problem if you take a point on the curve to calculate how many times you had to do the addition to reach this point. It's actually so hard that the number of addition is used as a private key and the resulting point is used as a public key. So let us check the demo. Enough mathematics, let's draw some pictures. No, that's not the right one. So first we will import the Nakasendo support for big numbers. And then we'll create a point. Every elliptic curve takes some parameters that define the shape of this elliptic curve. And we are using Nakasendo's big numbers here, okay? This actually means that the operation that we have seen in previous method, plus and minus and so on, are not operations that are performed on the native Python integers, but the Nakasendo's big numbers. So Python supports overloading of operators, so we don't have to call add method, we can just use plus sign. Then we'll draw a curve, okay? And here it is, our elliptic curve. It only has 20 points, so it's not a really secure curve because 20 private key is not very secure. And if we print out these points, we can see that the points is using the Nakasendo's big number for its coordinates. So let's draw a bigger one. This one is quite bigger, actually so big that if you would try to fit all the points on the screen, there's just not enough pixels. So we'll just take first 10,000 pixels. And to make this more fun, we make it interactive. So if you can see that quite bigger numbers are used here, and if I take 2 points, the red star is representing the sum of those points. And so if I keep repeating this process, the red star is jumping around like crazy, okay? So, and if you can tell me how many times I'm required to click to reach this point, then you could be a really rich person. Come to talk to me first, okay? So, this was a sample of 2 low-level APIs. For the last demo, we'll do a Keypuzzle demo. As I said, Keypuzzles are supported by the Nakasendo SDK, and they are also extensively used on MetaNet. So what is a Keypuzzle? Let's imagine that we have a resource that is protected by some private key. This could be a wallet of funds on some old chain like Ethereum or Litecoin or something like this. It could be a document that is encrypted and you need a private key to decrypt it, or it can even be an access to a physical resource like a car that I want to rent. And let's say that we have a Bob that wants to buy the access to this private key from Alice. What we will do, we will send such a transaction from Bob to Alice that it will use a special locking script that will force the Alice to expose her private key in order to spend the coins. To understand this, let's take a quick refresh on the digital signatures on elliptic curves. If you want to create a digital signature on elliptic curve, there are basically 2 steps. In first step, you choose a very large integer number, which is basically a for key, which is just a fancy word for a temporary key. And then you multiply this number by generator point, and while multiplying, this red star is jumping around like crazy, and it finishes in 1 point. And we take x coordinate of this point, this is just a part of the public key, and assign it to R. So to actually calculate the signature, we then use the M4L key, the hash of the message, our private key, and R. So the final digital signature is composed of 2 numbers, the S and R, and those 2 numbers are published on the blockchain as part of the signature. One important property of doing the signing in this way is that, and Sony learned this in a very hard way, is that you should never expose the referral key to anybody else, and you should never reuse the referral key. If you do this, then somebody else can extract the private key from your signature, which you don't usually want to do, but that's exactly what we'll be doing for the Keypuzzles. So we will, instead of letting Alice to choose her own referral key, we will force her to use the one that we have chosen, and when she does this, when she signs the message to claim the coins that we sent to her, we will be able to extract the private key from the signature. Okay, demo time again. There are free players in this demo. Okay, there is an online store where there are some interesting items that I could buy. Okay, and there is a buyer, me holding a phone, and there is a seller which is running on the Node.js server on this machine. And just a disclaimer: we are doing the demo for the crypto library, so we won't be actually constructing all the transactions. We will just collect the data that is required for the Keypuzzle. And we also didn't do the full integration with the money button yet. We are sponsoring the cocktail party there, so there will be time to finish it. We just took the picture. Okay. So when I select the item, the first one looks interesting. Price is a little bit high, but okay. I just swipe the money button. And that's it. The application tells us that we successfully extracted the private key, verified it, and we were able to use the private key to generate another signature. So, time to look at the code again. We'll take a look at the shop first. So shop is just a collection of the items. Okay, we have a price, a description for an item, a public key, which is used to identify the item, the address, which seller uses to receive the money. I should update this with the new money button addressing scheme. Okay, pretty picture, and the endpoint, which is used to do the off-chain communication with the seller. As you remember, we need to securely communicate the referral key to the seller. We could use blockchain and encrypt it, but we'll just post a message in this demo. The interesting things happens when I swipe the money button. There is a method on item selected. So the first thing that I should do is I should verify if everything is okay with the item. If the item represents balance in some address, I could just do this by checking the blockchain if the balance is still here. And then I will generate a payment transaction. And here I'm just using Nakasendo function to generate the referral key and record the public key and this referral key in the transaction that then I send to the seller. I sending it just by converting a transaction to the JSON and posting data to the Node.js server, which is running on this computer. So when seller receives the transaction, the first thing he should do is what? He should verify if the transaction is okay. What could go wrong with the transaction? Yeah, instead of 1 BSV, I could pay 2 or a half. Okay, so he must verify if the transaction is okay. And if this is okay, then he can publish the payment transaction on the blockchain. This could also be done on the buyer side. And then Alice needs to collect the payment. And if you remember from the slides, in order to collect the payment, he has to solve the Keypuzzle. This means signing the transaction with the right referral key. There's the functions from the Nakasendo SDK. It takes hash, it takes the private key and the inferral key that we've got through this web service call. And this private key here corresponds to the public key, which was published in the store. Please do not ever store the private key in your code like this. Use Nakasendo secret store, and please do not take photos of this private key. It's useless. Okay. It has already been spent. No double spending. So after we get the transaction, we just publish the second transaction to the blockchain and return it to the buyer. Again, buyer could extract this from the blockchain. You don't need a direct communication channel for this. So the last step on the buyer side is, so item was selected, we send the transaction to the pair. We need to extract the private key. And Nakasendo provides a function for this. It takes the signatures, the hash, the inferral key that we have used, and the public key. And in this extracted key variable, we get back the private key. So how can we check if the private key is correct? There are a couple of options, okay? The first is just take the extracted key, calculate the public key, and compare it with the public key that was published in the store. This was the first pop-up that you have seen on the screen. And the second is also a simple one. You just create a test message, sign the message with the extracted key, and then verify the message using the public key. And this was the second pop-up that you have seen on the screen. So what we have done is actually force the Alice. Alice was not able to collect the money until she solved our Keypuzzle, and by doing so, she exposed some information that we can use to extract the private key. Of course, this is just a demo. What could go wrong in the practice? At least two things. The first thing is if Bob sends transaction to the Alice and Alice does not reply because she's evil, she's rich or dead, then Bob loses money, okay? Then Bob loses money. And the other problem could be, okay, Alice is alive and she takes coins from Bob, but she's faster than Bob. And before Bob is able to claim the Ethereums, she moves the Ethereums to some other safe place. This is the second problem. Both of those problems are solved as a part of the Nakasendo SDK, but there will always be some application-specific checks that needs to be done. For example, Nakasendo will never, ever verify if a given public key belongs to a car that you can rent. This is application-specific check that must be done. So, we have seen a simplified version of the key puzzles. There are also more advanced techniques. You can chain those key puzzles together and so on. And as I say, they are used on the MetaNet, so maybe we'll be hearing about them in the further talks. Ready for questions?